Hello everyone, let's try and solve another problem. Use Lagrange multipliers to find the maximum and minimum values of f subject to the given constraint. So f of x is equal to x squared times y, and the constraint is x squared plus y squared equals 1. Okay, so, my first thought here was in fact that you don't have to use Lagrange multipliers to perform this. There's other ways of doing it with such a simple function and constraint, but we're asked to use the Lagrange multiplier, so that's what we'll do. I'm not going to explain any of the theory behind Lagrange multipliers and how they work or why they work. I'm just going to kind of go through the computations here. So the first is we're going to define a new function x, y, lambda like this. And I'm going to go through the computations of computing partial derivatives of L with respect to x and y. And then just, go through the algebra of solving for x, y, and lambda. And we should end up with a set of candidate solutions. So values of x and y, which are potential minima or maxima of this function. And then we'll just sort of have to consider all those candidates one at a time. Okay, so after writing down the system of equations that we need to solve, that's this system here. So we have 3 variables and 3 unknowns, although we really only care about the values of x and y. We don't care so much about lambda. I find a bunch of solutions. I find 5 possible pairs, x and y, that solve those equations. The first is given by 0, 1. And then the rest are given by root 2 over 3 and 1 over root 3 with all possible combinations of plus and minus in front of them. So then evaluating the function at all these points, I get 0, 2 over 3 root 3, and negative 2 over 3 root 3. And these values are repeated depending on the values of x and y. And so of all the candidates, clearly the maximum value is 2 over 3 root 3, and the minimum is negative 2 over 3 root 3. This just boiled down to understanding how to use a Lagrange multiplier and then crunching through some of the derivatives in algebra. I don't think I made any mistakes in this one, but if I find one at some point, or if I have any more thoughts that I want to make about this problem, I'll put them down into the description. Thanks for watching.